Hello there, ladies and gentlemen. My name is Roger Weitzel, and today we're going to do some math. And today we're going to talk about one of the greatest mysteries, or uh, Albert Einstein said that compound interest was one of the greatest mysteries of mankind. So today we're going to talk about that. So we're going to work on a problem here that shows up in one of our preparation. So what we're going to do here is go to this problem. So what happens here is we know that if we put money in the bank and it gets 5% after 1 year, that's not that exciting after 1 year. But this guy's held it in the bank for 16 years and he wants to know how much his money is worth now. So we got some formulas here that one of these formulas represents how we can do this, but we might not recognize it right off the bat. So let's talk about how do we calculate this interest. So the first thing we're going to do is to say we start out with $3,000 and we add 5%. So let's go to our text box and we're just going to say, how about if we take $3,000 and we add 5%. So what's that going to be equal to? Well, we might not be able to do that in our heads. The calculation is done by doing is 3,000 times, and then when we do arithmetic, we change the percent to a decimal, which is going to be 0.05. And that's going to give us 3,000 times 0.05 is equal to $150. So at the end of 1 year, we're going to have 3,000 plus 150 is equal to 3,150. So one of the things that we may not have talked about yet, but this is 3 steps. What we know is that there is a formula that says that if we want to work with a percentage increase or percentage decrease, that we can take the original price and multiply it by 1 plus or minus R. So what does that mean? The rate is going to be the percentage. And so if we're going to apply it to this situation, this would be 1 plus 5%, 1 plus 0.05, which is equal to 1.05. So the new price is going to be equal to erase So if we apply it to this situation, we could say that we had $3,000 and we multiplied it by 1.05, and that gave us the 3,150. So the advantage of doing it this way is that we can recognize that a pattern is being set up here. So you recognize now that we have 1.05, and that shows up right here. And I am going to make the prediction that this is the formula that we want to use, but let's talk about why. Now, with compound interest, what happens is each year we're dealing with a new reference number. This becomes the new number that is has the 5% added to it. So after the first year, the second year, we're going to have 3,150 and multiply that by 1.05. And when we do that, now the new number becomes okay. What we notice is that we have the standard formula, 3,000, and we're multiplying it by 1.05, and that's going to give us a new number. And then we're going to take that number and multiply that by 1.05, etc. And we are going to do that for 16 times in a row. Well, this pattern obviously represents something that we can raise to a power. So instead of writing this out like this, what we're going to do is to write this as $3,000 times 1.05 and raise it to the number of years. So we're going to say, if we take that to the number of years, which we're going to say is T. So if we now figure out what we have here, we have 3,000 times 1.05, and we're going to raise that to the 16th power. And now we're going to see how much money did this guy make by leaving his money in the bank for 16 years. He's only making 5%, but he's keeping it in there for a long time. So let's see what 3,000 times 1.05, and we want to raise that to a power, so we're going to say y to the x, 16 equals. So he's more than doubled his money, even at just a low interest rate of 5%. He's going to have $6,548.62. Now, this has reminded me of when I first got into investing. They were talking about a little trick that you could use to kind of estimate how quickly you could double your money. And it was called the rule of 72. What that rule says is, if I take 72 and I divide it by the annual interest rate as a whole number, I can get an approximation of how many years it's going to take to double. So if I take 72 divided by 5 equals, it's going to take 14 years to double. And you can see it doubled, and we even got an additional $548. So I'm going to practice this lecture a couple more times because that was kind of rocky. So let's go ahead and stop sharing that, and we're going to stop recording.